Hi, my name is Galen Tunnicliffe, and today I'll be presenting Lab 4, Circuits and Capacitors. So the contents, we have the introduction, fundamental concepts, the data collected, and the results and the questions that we have to answer. For the introduction, the main description of the experiment, using either in-person equipment or a simulation which I used, measure the effects of resistors and capacitors throughout different roles in a circuit. I used the PhET simulations to recreate these reactions, and I also used Ohm's law to make initial predictions, then compared and plotted results from the simulation. Fundamental concepts, one is Ohm's law, V equals IR, the node rule, and then Kirchhoff's loop law, which is the voltage sum around the loop is equal to 0. So the quick data collected is that we predicted the amperage based on Ohm's law to be 0.02 amps. The model reflected this. As predicted, the reversing the connections creates opposite sign in the ammeter. The voltage measured at the point of the ammeter is 3 because previous to any load, and there is no current because it is opened by the voltmeter. Voltage drops from resistors. The resistor 1 was 0.96 volts, resistor 2 was 2.04 volts, and it was negative 1.5 volts for the battery. Sums to 0, so it makes sense. So this is just a quick graph of what we collected. You can see this is the voltage, and it all goes to 0 at the end. Okay, this is just a quick overview of how I set up the voltmeter to test later experiments. Okay, so for the RC data, we had a 10 ohm light bulb circuit that required 16.12 seconds to discharge and recharge. It was symmetrical. And then we had a 20 ohm light bulb circuit that required 29.96 seconds to discharge and recharge. So part of our observations here is that the electric force decreases while the capacitor charges. Quick data collected. So we see up top here we have the delta V versus time. So as you can see, as the capacitor discharged, it discharged a lot initially and then it kind of fell off. Linearized versus ln delta V over delta V naught, you can see that it's linearized. So it was in relation to e to the x. The RC value reached roughly 6.45. If we were doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter, the numbers would be slightly less accurate as it takes a slight load and cannot read the amperage perfectly. Again, if we did in real life use a real battery to charge a real capacitor with no resistor in the circuit, our ideal model would predict the capacitor to full charge at the speed of light as there's no resistance between the battery and itself. In reality, it would be slightly less due to the resistance in the battery and the wire, but still quite possibly damaging to the components of the circuit. Yeah. Alright, but that's the end of my lab today, and thank you for listening.